Without a doubt, the single most important component in any vehicle is the braking system. This is especially true on heavy trucks, which can weigh 20 to 30 times the weight of the average passenger vehicle. It is unfortunate that some truck drivers do not fully understand the operation of heavy truck brakes, especially when one realizes that the tractor portion of a tractor semi-trailer rig may have 10 or more valves controlling the airflow to the brakes. Now add to this complexity, the truck driver operator may have as many as 4 different ways of applying brakes on his vehicle. To emphasize the importance of braking systems on commercial big rigs, let us look at 2 very important facts. First off, deficient brake components are at the top of the list in heavy trucking vehicular accidents. The next startling fact is that brake component violations are one of the top categories in roadside, scale, or FMCSA inspections. The brake systems on heavy trucks are broken down on the driver-operator's daily safety checklist. Worn, broken, or malfunctioning brake system components noted on their inspections are to be noted in writing and the vehicle deadlined until these faulty components have been repaired or replaced. Brakes are a heat engine. They convert kinetic energy, motion, into thermal energy or heat. It is interesting to figure out just how powerful your brakes must be to do the job of stopping your rig. Suppose you've got a 400 horsepower engine and you're grossed out at 80,000 pounds. Your engine can probably get you to 40 miles per hour in a quarter mile. That's 1,320 feet. Your brakes should be able to stop you in about 133 feet with this speed and weight, making them 10 times as powerful as your engine. Now we should begin to comprehend the importance of a continually well-maintained braking system on these monster big rigs we put on the road. We now want to take a look at the 2 main types of overall braking systems used on the big rigs. First off, we have the older non-ABS system, which, when the brakes are applied with too much force, tend to cause the braking axles, especially the steering axle, to lock up, causing the tires to lose traction with the roadway, and a skid is the result. A big rig with an enclosed trailer, flatbed trailer, or a dump box behind it will tend to have that trailer either cause the tractor to jackknife or cause trailer swing out, where the trailer slides sideways across adjacent lanes of traffic or to the side of the roadway traveled. The second, more efficient braking system is known as ABS. The drum or disc brake components work in the same manner as the non-ABS system, with one big exception. That exception occurs when the brakes are ready to lock up and cause the skidding effect. Sensors then relay that information back to a small computer component, and at that moment, the computer takes control of the braking maneuver, causing the brakes to pulse, which in reality is an applied on-off action of the brakes, causing the pads or drums to engage-disengage in microsecond intervals, which keeps the wheels from locking up and causes a skip instead of a skid effect, and that allows the vehicle to stop straight and in a much shorter distance. At the wheel, there are 2 distinctly different types of brake components, each charged with doing the same job, namely, intentionally interfering with the forward motion of the vehicle through braking, ultimately bringing the vehicle to a safe stop. The first and older component system used is drum brakes. In this system, when the transmission medium, air, is applied, the brake pads are forced apart from their rest position by an actuator and make contact with a metallic round hub known as the drum. The force exerted by the pads on the drum causes friction where the pad contacts the steel drum, creating heat energy and therefore the braking action. The second, newer, and more efficient component system used is disc brakes. With this system, there are disc pads which, when the transmission medium is applied, are contracted inwardly by an actuator until they make contact with a stationary round steel disc. From that point on, the same physics laws that applied to drum brakes apply to disc brakes, only in a more efficient manner, allowing vehicles to stop sooner. As every truck driver operator knows, most heavy trucks use compressed air, generated by the operation of the truck and stored in tanks attached to the trailers, to operate the vehicle braking system. What many truckers don't know is the whole reason compressed air is used as the transmission medium to apply big rig brakes, whereas hydraulic fluid is used in cars and light trucks for the same purpose. One reason for the use of air brakes is the ease in which trailers may be connected and changed out by reconnection of air lines and without concern for spilling hazardous hydraulic fluid. Another reason is that the technology for compressing air and storing it is well understood. Now, to the most important reason why air is used as the transmission medium on heavy trucks. While brake fluid in a car is merely used to transfer the muscular force of the driver's leg to the wheels, amplified by the master cylinder and a power booster, the air system on a truck actually generates the braking force. The truck's brake pedal is little more than a foot-operated air valve, treadle valve, which modulates the amount of air supplied to the service brakes of the truck. With an air brake system, there is no manual override or push-through to allow the driver to pump up the brake pressure as in a car, because even a strong man could not possibly generate enough force to stop an 80,000-pound truck in a reasonable distance. A typical Type 30 brake chamber generates approximately 1,800 pounds of force at an air pressure of 60 psi. An 18-wheeler has 8 of these chambers and 2 smaller ones for a total of over 16,000 pounds of force at the pushrods. How does the braking system on a big rig work, you ask? The service brakes, for normal braking, of most heavy trucks consist of air tanks located near each grouping of axles. These tanks are kept charged with compressed air whenever the engine is running. When the brake pedal is depressed, air pressure in a signal line is increased, causing a service relay valve at each tank to send air to the brake chambers. Use of a signal line reduces the volume of air that must pass through the foot valve and speeds brake response, since most of the air used to fill the brake chambers is supplied from a nearby tank, not from the distant main reservoir. Air leaks are the nemesis of an air brake system. All new trucks must be equipped with a dual-air system so that if one circuit fails, emergency braking function is maintained. This redundancy is accomplished by using a series of valves and air lines providing duplicate sources of air to the wheels. A tractor protection valve automatically isolates the tractor from the trailer if there is an air leak in the trailer brake lines or if a breakaway trailer situation develops. This feature allows the driver to stop the tractor normally. In addition, in a trailer breakaway situation, the spring brakes or relay valve reservoir system on the trailer should automatically apply the trailer brakes when the air supply line from the tractor is broken, creating a no air pressure situation. Another type of braking system on newer trucks is the spring brakes, which also serve as an emergency braking system. When the truck is parked, no air pressure, a heavy spring inside the brake chamber automatically applies the brakes through residual air pressure. After the engine is started, the driver supplies the top half of the chamber with air, compressing the heavy spring. Now, when the brake pedal is depressed, supplying service air to the bottom half of the chamber, the brake system now functions as a normal service air brake system. Spring brakes will lock the brakes in an emergency, no air pressure situation, but allow controlled application for parking. Despite the redundancy built into new truck brake systems, everything is dependent upon friction between the pads and the drums or discs. That means that if brake pads, discs, and drums overheat during a long downhill grade, causing excessive wear and warping, none of the emergency systems will help. Here is where the driver-operator's knowledge and expertise in braking methods, along with speed reduction, come into play. Slower speeds and engine braking, shifting to lower gears, save the brake pad material and save the brakes from overheating, breaking down, and ultimately failing. By earnestly performing the required daily inspections on your vehicle and seeing that all necessary repairs are effected, along with the vehicle owner providing a stringent maintenance program, all systems working properly, including the brake systems, will cause the vehicle to continue to be roadworthy and safe.